All right, I'm going to go over several problems from assignment 31 that I saw on the homework parking lot. A lot of these really are exactly the same type of problems we've done in class. So, really you should be looking back at what we've done in class and when you're doing your homework. For instance, the first problem, this is from page 378. This is number 14, which it says find the acute. Hold on one second. Lost the page. Find two supplementary angles formed by the line 3x plus 2y equals 5 and the line 4x minus 3y equals 1. Well, in class, we found the angle between two lines by using the slopes of those lines, which were the tangents, and we used this identity to find the tangent of the angle between. And this is no different. The only difference is you have to actually do some algebra and take each equation and find the slope. So when I solved this equation for y, I got the slope was negative 3/2. I solved this equation here, I got the slope was 4/3. I sort of roughly sketched those points. It doesn't really matter where the y-intercept is. Okay, I really can consider the origin to be where those things cross. Okay, this angle here I can call alpha, and I know the tangent of that angle is the slope. So the tangent is negative 3/2, and this angle here has a tangent of 4/3. So I can just use the identity. This is literally exactly what we did in class. So the tangent of alpha is 4/3, if that's the one I'm calling alpha, minus the tangent of beta, that's negative 3/2, over 1 plus 4/3 times negative 3/2. Okay, that's going to give you the tangent of the angle. Okay, so let me pause this and do some math. All right, so I didn't really feel like doing all this fraction work, so I just typed in the calculator this expression, making sure I had all my parentheses right. That's the tangent of the angle. Okay, and so if I want to find the angle, I just do the inverse tangent of that, and that tells me that one of the angles is 43.36 degrees. Well, the other angle, it's got to be the supplement of that. So I'll just do 180 minus that answer and get about 137 degrees. So we're talking about 43 degrees and 137 degrees, which this problem was literally right off of what we did in class. Next problem was number 28, which just said, and this is actually literally the first problem we did in this chapter. We did it in class. So this is kind of the theme of some of these homework questions. Verify that in a triangle, if you add the tangents of the angles, you get the same thing as if you found the products of the angles. And it said verify that, so we're not proving it, we're just picking some angles and seeing that it works. This is exactly what we did in class, so I'm not going to go over that one. All right. Other problems that people asked about. From page 383. All right, number 24 was asked about. First of all, it said that angle A is acute. So that's important, which means it's in the first quadrant. And it said the cosine of A is 1/4, and it said find sine 2A and find the sine of A over 2. So we're just going to apply the identities. Okay, we know that that's the identity for this. And we know that for the sine of A over 2, we just can either look that up, and we derived it in class. It's 1 minus the cosine of alpha over 2. Or A, I guess, over 2. It's plus or minus. Now, we have to consider where A is. Well, it says A is acute, so it's in the first quadrant. So if the cosine is 1/4, it's something like this, where this is 1, this is 4, and so you have to figure out what this is, so it looks like that's square root of 3. 1 squared plus the square root of 3 squared is not 4 squared. So what the heck is this? Square root of 15. Okay, you get 1 squared plus the square root of 15 squared equals 16. That would work. So that's the square root of 15. And so now I just plug in. I literally just plug in. Okay, if I'm going to find the sine of 2 alpha, 2a, well, I do 2 times the sine of a, which is not given to me, but it's the square root of 15 over 4, times the cosine of a, which they do give us, 1/4. Okay, so this is 2 root 15 over 16, which is root 15 over 8, looks like. Okay, so that's the sine of a. Sine of 2a, I'm going to use this formula right here. Okay, now plus or minus. Well, if a is in the first quadrant, half of a is in the first quadrant as well. So think about that. So it's got to be positive, and so I'm just going to plug into this formula. 1 minus 1/4 over 2, that's 3/4 over 2, which is the square root of 3/8. All right, so that was number 24. 26 through 28 we're asked about. These are really simple. I'm not going to go over all of them. 26 says, find the sine of 75 using A, the addition formula. Okay, so that's just writing 75 as the sum of two angles that we know the sines of, or cosines of. They're special angles. So I can do 45 plus 30. Okay, and then I can write sine 45 degrees, cosine 30 degrees, plus cosine 45, sine 30. Okay, and then you know these things. I'm not going to go through all that. Okay, the other said use the half angle formula. Well, 75 degrees is half of 150 degrees. And 150 degrees is one in which we know the sines and cosines of. So I'm just going to plug in to the half angle formula, which is plus or minus, same one we used up here. 1 minus cosine of this, in this case, 150 degrees over 2. Okay, now thinking about 75 degrees, it's in the first quadrant, so the sine is going to be positive. Okay, and then I'm just going through this. 150 degrees is right here. The cosine of 150 degrees is 1/2, I believe. No, root 3 over 2, negative root 3 over 2. So this has got to be 1 minus root 3 over 2 over 2. And I can simplify that, but that's my process here. All right? People asked about 27 and 28. These are literally just graph them on the calculator and then give the range and the period of the function. All right, so put your calculator in radian mode, graph it, and then just see what it looks like. You might have to change the window to get a good look at what the period is or whatever, but it's really simple. So just follow the directions and you should be fine.